Hello dear student, myself Dr. Anjana Singh Tomar. Today I am going to discuss about water softening methods. So student, there are basically two types of water softening methods, external treatment method and internal treatment methods. External treatment is also known as preventive method because when water is treated outside the boiler or before feeding the boiler is known as external method, and we are taking precaution before feeding the water, so we are also saying it preventive method. Internal treatment method is also known as corrective method because after doing some corrections or after feeding some hard water by mistake, we only do correction. External treatment method are of three types: lime soda method, zeolite or permuted method, and ion exchange method. Internal treatment are of four types: colloidal conditioning, carbonate conditioning, Calgon conditioning, and phosphate conditioning. First, we will discuss about the external treatment or preventive method. This method contains three types: lime soda process, zeolite, and ion exchange. So student, first we will discuss about the lime soda process. Lime soda process is also of two types, and it is based on the principle that highly soluble hardness causing salts or impurities convert into insoluble precipitate by chemical reactions is the basic principle of lime soda process. That we can say the basic principle of this process is to chemically convert all the soluble hardness causing impurities into insoluble precipitates, which may be removed by settling, filtration, and blow down operation. Lime soda process is also of two types: cold lime soda process and hot lime soda process. Cold lime soda process can also be divided in two parts. First, intermittent cold lime soda process, and second is continuous cold lime soda process. Now we will discuss about the intermittent or batch type cold lime soda process. It is also known as batch type method because when we take small amount of water and perform this process, this is known as batch process. An intermittent type cold lime soda process softener uses two tanks operating alternative to soften water. Each tank has inlets for raw water and chemicals, outlet for softened water and sludge, and a mechanical stirrer. In this apparatus, you can see we have two inlets. This inlet is for raw water and this is for chemical inlet. In cold conditions, we always use lime, soda and coagulant. And if we take hot conditions, in hot condition there is no requirement of coagulant. We have two outlets also in this apparatus. This is softened water outlet and this is sludge outlet. This is a mechanical stirrer which is used to mix the chemical and water. When we feed raw water from this side and chemical, lime soda and coagulant, we will mix this with this stirrer, and after some time when reaction completed, we keep it undisturbed for some time, and after that when some particles or insoluble particles are settled at the bottom, we can collect it by blow down operation from this outlet, and we can also collect salt water from this outlet. This is the continuous cold lime soda process. This apparatus is somewhat different from intermittent process. That was a rectangular apparatus and this is a cylindrical apparatus with conical bottom. Conical bottom is modified because it gives the proper collection of sludge. This apparatus has two chambers. One is inner chamber, reaction chamber. It is known as reaction chamber because water and chemicals mix in this chamber and reaction perform. And this is sedimentation chamber because sediments are collected in this chamber. If we talk about the process, From this inlet, we feed the raw water in this reaction chamber, and from this inlet, we feed chemicals, lime, soda, and coagulant in this chamber. It is connected with an stirrer. It is connected with motor and driving belt. And when we mix chemical and raw water in this center part in reaction chamber, reaction perform, stirrer continuously stir the solution and mix both the chemical and water. And when the reaction perform, water and slush come outlet of this chamber. Sediments or slush can collect at the bottom of the apparatus, which can be removed by blowdown operation, and the soft water come at the upper side, which is filtered with this wood fiber filter. There is somewhat difference in both the apparatus. Intermittent has a rectangular bath. Continuous process has a conical shape, cylindrical bath. It has two chambers and that process has only one chamber. In this apparatus, we are also using this wood fiber so that fine particles can also filter with this wood fiber. There are some points which we have to learn. This process perform at room temperature about 25 to 30 degrees centigrade. This reaction is performed at cold condition, means at room temperature. That is why this reaction is very slow. The precipitate formed in this form of fine particles, so it do not settle down easily and hence filtration is not easy. So that it is essential to add small amount of coagulant such as alum or sodium aluminate. The water obtained contains residual hardness about 50 to 60 ppm. Now we will discuss about the hot lime soda process. In this process we have three parts. In cold condition, continuous chamber, we have two chamber, reaction chamber and sedimentation chamber. But in hot lime soda process, we have three chambers. One is reaction chamber where reaction perform. Second one is sedimentation chamber where sedimentation occurs. And the third part of this apparatus is filter. This is a gravity filter. Gravity filter works on the gravitational force. This apparatus has three inlet, one for superheated steam, second raw water inlet, and third is for chemical inlet. This container also have two outlet, one for sludge outlet and second is filtered and softened water outlet. Now we will discuss about the process of this instrument. Hot lime soda process, reaction perform at hot condition. Hot condition means about 90, 95, 80 degrees centigrade. Okay. And in cold condition, we were performing the reaction as room temperature, 25 to 30 degrees centigrade. In hot condition, we perform it at higher temperature. As we all know, the steam always generate at 100 plus degrees centigrade, and when we enter this superheated steam in this chamber, it will comes in contact with this raw water and chemicals. Then the temperature somewhat slow down and it is about 80 to 100 degrees centigrade. When we mix raw water, chemicals and superheated steam in this chamber, reaction perform in this reaction chamber, and after completing the reaction, sediments collected at the bottom of the chamber and soft water comes at the upper surface, which will pass through gravitational filter. After filtering the water, we can collect it from this outlet. Student, there is some point to remember. The temperature of this process is 90 plus. This reaction is very fast because at cold conditions reactions normally conduct slowly, but in hot conditions reaction perform fast. Precipitate formed settled easily, so the filtration is easy in this hot conditions. No coagulant is required in this process because reaction is already performing at hot conditions and the residual hardness is 15 to 30 ppm. It is a point to be noted that the residual hardness of cold lime soda process was 60 ppm, 50 to 60, and hot lime soda process it is 15 to 30. There are some differences we should remember. Then cold lime soda process perform at room temperature and hot lime soda process perform at hot conditions about 90 plus temperature. Cold lime soda process is slow process and hot lime soda process is rapid process. Coagulant is must, it is compulsory in cold lime soda process, and in hot lime soda process coagulant is not required. Filtration is not easy in cold process, and in hot process filtration is easy because insoluble particles are formed properly. In cold conditions, residual hardness of water is about 50 to 60 ppm, and in hot conditions it is 15 to 30 ppm. The dissolved gases are not removed, but in hot conditions, when we heat the water, dissolved gases already removed and oxygen, carbon dioxide like gases removed to some extent. In cold lime soda process, low softening capacity, but in hot lime soda process, high softening capacity occurs. So that was the lime soda process. Now we will discuss about the second process. This is known as zeolite or permuted process. Zeolite means to boil. It is a Greek word. Geo means to boil and lithos means stone. Zeolite means we can say it is boiling stone. This stone is used for filtering the water, softening the water. Basically, if we discuss about the zeolite, zeolites are naturally occurring hydrated sodium aluminosilicate minerals. This is the chemical formula: Na2O, Al2O3, X SiO2, Y H2O. We can differentiate the polymer with this X and Y values. X may be from 2 to 10 and Y may be 2 to 6. Zeolite are also known as permutates. If we see the type of zeolite, they are of two types: natural zeolite and synthetic zeolite. If we discuss about the natural zeolite, they are non-porous, amorphous, and the example of natural zeolite is natrolite. You can see here only silicon and water amount is different and the whole formula is same as the normal zeolite. If we discuss about the synthetic zeolites are the zeolite which can be prepared in laboratory, or we can modify these zeolite at laboratory according to our requirement. These zeolites are porous and possess gel-like structure. See this structure? These are the aluminum particles. Three aluminum particles are arranged in triangle. These aluminum particles are connected with oxygen. These are the oxygen molecules. And these oxygen molecules are connected with silicon molecule. Okay, this is the full structure of zeolite. You can see that there is one cavity in the center of zeolite. This zeolite is synthetic and it is modified in laboratory. So we can easily say it has one cavity. This cavity has sodium ion inside it. You should also know synthetic zeolite have higher exchange capacity of cations. This is the zeolite softener. First we will discuss about the softener. This softener is a cylindrical apparatus which has two inlets, one for raw water inlet, second is for regenerator inlet. It has one outlet for salt water and second outlet for sludge or waste. In this apparatus, there is one zeolite bed. This zeolite bed contains many sodium ions, which can be easily replaced by calcium and magnesium present in hard water. This is the gravel filter, which will help us to filter the water, filter the insoluble particles. Now we will discuss about the process. For softening of water by this process, it is passed at a specific rate through zeolite bed kept in cylinder. You can see we pass raw water in this inlet. When we spread over the zeolite bed, it will filter and we can collect it at the bottom. Zeolite hold sodium ions loosely and it is represented by Na2Ze, where zeolite represent insoluble radical framework. The hardness causing ions, calcium, magnesium, etc. are retained by zeolites as a calcium zeolite and magnesium zeolite. We can also say that zeolite captured the calcium and magnesium ion while outgoing water contains sodium salt. These are some reactions. This is the zeolite which has sodium ion. When it reacts with calcium bicarbonate, it will capture the calcium and gives sodium bicarbonate. When zeolite react with magnesium bicarbonate, it will capture the magnesium ion in it and will give sodium bicarbonate. Same as chloride and sulfate, when it reacts with calcium chloride and calcium sulfate, zeolite will capture calcium ion and will give sodium chloride and sodium sulfate. And when it reacts with magnesium chloride and magnesium sulfate, it will capture magnesium ion and give sodium chloride and sodium sulfate. You can see in this apparatus, after filtering the water with gravel filter, we can collect it by this outlet. You should notice that at two places I have write open and open, and at two places we have write close and close. It means when we are performing the softening method, we open this passage. When we water pass through zeolite bed, it will come through gravel and we can collect it through outlet. It is the softening passage, and when the zeolite bed is exhausted, how can we understand that bed is exhausted? When all the sodium ion present in zeolite are exchanged from calcium and magnesium, then the zeolite bed will exhausted. And at that condition, we should regenerate or wash the zeolite bed for the further process. Regeneration. Regeneration or washing means when zeolite is completely converted into calcium magnesium zeolite, it ceases to soften the water. It gets exhausted. At this stage, the supply of hard water is stopped and the exhausted zeolite bed is regained by treating the bed with 10% NaCl solution. This is the reaction. When calcium zeolite react with NaCl, it will again regenerate and gives calcium chloride. When magnesium zeolite reacts with sodium chloride, it will again regenerate and also gives magnesium chloride. See in this apparatus, this injector is used to send NaCl forcefully in this bed. This is the NaCl regenerator. NaCl is using a regenerator because we want sodium ions in this zeolite bed again. When we send this NaCl through injector forcefully in this zeolite bed, this zeolite bed is washed through NaCl. We can collect here calcium chloride and magnesium chloride, and calcium magnesium chlorides are sent to sink. This is the simple regeneration process or washing process. These are exhausted zeolite and these are the regenerated zeolite which are again ready to soften process. The washing containing calcium chloride and magnesium chloride is passed into sink and the regenerated zeolite bed obtained is used again for softening purposes. Now the third process is ion exchange process or deionization demineralization process. D means removal. Deionization means removal of ions from the water or demineralization means removal of mineral from the water. Again, we are revising some facts. Lime soda process was based on the theory that soluble particles are converting into insoluble particles and was removing through blowdown operation. In zeolite method, cations are exchanged from sodium ion, but in ion exchange method, both the ions are exchanged in this method. Actually, ion exchange resins are insoluble, cross-linked and long-chain organic polymers which porous structure and the functional group attached to chains are responsible for ion exchange properties. In this process, we can exchange both type of ions, cations and anions. Cations means calcium and magnesium or other cations are exchanged to this hydrogen ion. Now we discuss about the resin. In this apparatus, we have two types of container or apparatus. You can see in this diagram. This is cation exchanger and this is anion exchanger portion. Cation exchanger resin is basically a polymer. It is known as styrene divinyl benzene copolymer, which is on sulfonation or carboxylation becomes capable of exchange their hydrogen ions with cations of water. This is the structure of it, right? Such resin have acidic functional group. Acidic functional group means sulfonic acid, carboxylic acid or phenolic OH group. Cation exchanger resin are capable of exchanging cations from hydrogen ions. If we discuss about the commercial name of cation exchanger is Amberlite IR120 and DOX50 are commercially available cation exchanger resin. And this is the anion exchanger resin. Anion exchanger resin have the OH ion which is capable of exchanging anion. These are styrene divinyl benzene copolymer. If you remember, both the polymers are same in cation exchanger resin and anion exchanger resin. Only the functional groups are different. It contains basic functional group like amino, quaternary ammonium, etc. These after treatment with dilute NaOH solution becomes capable of exchanging OH ion with the anion in water, hence called anion exchanger. If we call the commercial name, it is known as Amberlite 400 or DOX3. In market, they are available with these names. This is the structure of anion exchanger. Now, as we know, this cation exchanger have hydrogen ion to exchange and this anion exchanger has OH ion to exchange. Now we discuss the process. The hard water is passed first through the cation exchange column. This is the cation exchange column. The water passed through this inlet. When we spread through overall the cation exchanger bed, it passes through gravel and comes down. After passing from cation exchanger bed, all the hydrogen ion will react with negative ions or anions of the hardness and they will receive at this place at the acid like HCl, H2SO4 and carbonic acid. We can also say that after performing cation exchanger process, we will receive the acidic water. And after receiving this acidic water, we pass this water through this pump. Pump is required because we required some force to throw this water from this anion exchanger bed. When we pass our acidic water from this passage, it passes through anion exchanger bed, and when acids are passes through this bed, it will replace all the negative ion will replace with this anion exchanger bed from OH, and I will get OH and H ion in the form of water. Now we can see in this reaction, the hard water is passed first through the cation exchanger column, which remove all the cations like calcium, magnesium from it, and an equivalent amount of hydrogen ion are released into water. This is the reaction. You can see how hydrogen is replacing the calcium and magnesium is also replacing the calcium. After cation exchange column, the water then passed through the anion exchanger column, which removes all anions like sulfate, chlorides, bicarbonates present in the water, and equivalent amount of OH are released into the water. It will react with chlorides and we will get the OH ion again. Hydrogen and OH ion released from the cation and anion exchange column combines to produce water as follows. And that was our target. Thus, water obtained is free from cation and anion. This anion free water and cation free water is known as deionized or demineralized water. Again, as we discussed in zeolite PET, after performing the reaction, when this cation exchanger bed and this anion exchanger bed get exhausted, it is required to perform regeneration process. This cation exchange bed will regenerate by acid regenerator. The best acid regenerator is HCl. And this anion exchanger bed will regenerate with alkaline regenerator like ammonium hydroxide. This is the injector. We can send these regenerators through this injector by forcefully. And when they wash the bed, cation and anion exchanger bed, they will again regenerate to perform the next reaction. The exhausted cation exchange column is regenerated by passing a solution, dilute HCl or sulfuric acid. It can be represented as this reaction. You can see how calcium is replacing again hydrogen ion, and now this is the regenerated resin. The exhausted anion exchange column is regenerated by passing a solution of dilute NaOH. The regeneration can be represented as, you can see how sulfate ion is exchanging the OH ion, and after that we can get again anion bed, regenerated anion and cation bed. So now I would like to discuss some differences between all three processes. As I already discussed, lime soda process is simple. When we mix water, lime, soda together, reaction performs, soluble particles convert into insoluble particles, and we can collect it after sedimentation or after blow down operation, we can remove it from water. In zeolite method, it works on cation exchanger process, and when we pass water through zeolite exchanger, water sodium ion exchange all the calcium and magnesium ion, and after reaction, after process, we get sodium ions in the with the water. In ion exchange method, in ion exchange method, we use cation and anion exchanger bed, and both the cations like calcium, magnesium, anion like bicarbonate, chlorides and sulfates are captured here, and now the resulting water is pure soft water, and after washing these instrument we can again use it for the further process. After completing the external process, now I would like to discuss internal treatment method, because if by mistake some hardness or some impurities are feeded into the boiler, they may damage the boiler or they may corrode the boiler. There may be scale slash problems, there may be casting embrittlement problem or boiler corrosion or any type of priming, foaming or any type of boiler problem. So that we use internal treatment method or corrective method. For this method, we should know which type of impurity present in the boiler. In this method, the water is treated inside the boiler. It is corrective method to remove the residual hardness. In this process, an ion is prohibited to exhibit the original character by complexing or converting it into other more soluble salt by adding suitable chemicals. Internal treatments is followed by blow down operation. There are four types of internal methods: colloidal conditioning, carbonate conditioning, phosphate conditioning, and Calgon conditioning. Colloidal conditioning is a method which is used in low pressure boiler. For this method, we add substances like kerosene, tannin, and agar-agar, etc. And when insoluble particles convert into heavy particles, we can remove it blow down operation. Blowdown operation is the partial removal of concentrated water through a tap at the bottom of boiler and replacing it with fresh water when the extent of hardness become alarmingly high. Second method is carbonate conditioning. This performed in high pressure boiler when the calcium impurities are exceeded in boiler water. We add excess amount of soda. Soda means sodium carbonate. When sodium carbonate reacts with calcium, it will convert all the impurities into calcium carbonate, which can be easily collected by or removed by blow down operation. In phosphate conditioning, we use phosphate for removing the insoluble particles. In this process, scale formation is avoided by adding sodium phosphate, which reacts with magnesium and calcium salts and form non-sticky and non-adhering, non-insoluble precipitate of calcium magnesium, calcium phosphate and magnesium phosphate, which can be removed by blowdown operation. You can see this reaction when metal chloride is reacting with sodium phosphate, it is giving metal phosphate and sodium chloride. When metal sulfate is reacting with sodium phosphate, it is producing metal phosphate and sodium sulfate. These metal phosphates are insoluble, non-sticky precipitates which can be removed by blowdown operation. It is very important to select the correct phosphate. It depends on the alkalinity of boiler feed water. We can use three types of phosphate. Sodium phosphate is purely alkaline. Disodium hydrogen phosphate is for medium alkaline water or medium acidic water, and sodium dihydrogen phosphate is used for highly alkaline water. The last internal method is Calgon conditioning. Calgon is basically the sodium hexametaphosphate. It is the formula Na2Na3PO4 whole 6. It is known as Calgon. It involves addition of calgon into boiler. It prevents scale formation by converting into highly soluble complex compound which are harmless to boiler. It is somewhat different method because each and every method we were studying that highly soluble complex particles convert into insoluble complex and we remove it by blowdown operation. In each and every process we were discussing that soluble particles convert into insoluble particles and we can remove it by blowdown operation, but only this reaction in only this method the calgon convert in low pressure and temperature boiler. Calgon converts insoluble particles, especially calcium particles, into calcium hexametaphosphate. and it is the highly soluble stable complex. It is somewhat different, which is harmful to boiler. It prevents scale formation by converting into soluble complex compound. You can see this reaction. Calcium sulfate is reacting with sodium phosphate. It is converting into soluble complex calcium hexametaphosphate, and after the reaction we can get highly soluble complex which is not harmful for the boiler. And in second type, when sodium hexametaphosphate reacts with water, it will convert into sodium orthophosphate, and again in high pressure temperature condition. Remember, in both the conditions, temperature and pressures are different. In low pressure and temperature, only calgon reacts with calcium, but in high temperature and pressure, calgon convert into sodium orthophosphate, and after that it react with calcium. And after reacting with calcium, it will convert into calcium orthophosphate. It is a loose slush and we can collect it with blow down operation or we can remove it easily. Calcium orthophosphate, highly insoluble particles, then this is somewhat different. Now I would like to discuss some points to be remembered. In lime soda process, the residual hardness in cold condition was 50 to 60 ppm. In hot condition, it was 30 ppm around, and in zeolite method, it was 10 to 15 ppm. Remember, residual hardness of zeolite method is 10 to 15 ppm. And after performing in ion exchange method, the residual hardness is 0 to 2 ppm. That means hardness should be completely removed. And after the ion exchange method, hardness is completely removed. But if by mistake 1 or 2 ppm hardness is and again remain in water, we can perform internal softening method. After knowing the type of hardness, after knowing the impurities in water, we can perform internal softening method accordingly. Thank you so much. Thank you.